Can you see my screen?
Yes, sir.
Yes, sir.
Yes, sir.
Okay, so now we go for integration. So, couple of basic notions that you have to understand here, and this is only to, the course is not a course on analysis, right? It is a course on uh, mainly on the methods. So though we are going to see what is happening on at the intuitive level, but we are not going to see everything in detail. Okay, so there will be a couple of definitions on the slides which are given to make you understand uh, the construction of the integral, double integral, triple integral at the intuitive level. Okay, mathematically it is not rigorous. And then after understanding the double and triple integrals, we will solve some problems. Okay, so our focus will be more on problems rather than on the technical side of the discussion. If you want to learn the technical side of the discussion in more detail, you will have to take a course, full-fledged course on analysis. Okay, then only you will be able to understand everything. So basically, whatever you are seeing on couple of slides, 2-3 slides or something, it will be a complete course uh, there. Okay, so our focus is not that. Our focus is to learn everything at intuitive level, geometric level, and then uh, use our knowledge to solve the problems. Okay, so in that line, first we will see this definition of partition of an interval. So let A and B be an interval, and let us assume that this is a closed interval. Then partition of the interval means that you look for the point x naught. You can say that x naught is A, point x1, so on to xn minus 1 and xn is equal to B, in such a way that x naught is less than x1, x1 is less than x2, and so on, xn minus 1 is less than xn. Okay, so that means if you have this interval A to B, you say that A is my x naught, and then you choose x1, x2, so on to xn minus 1, and B is xn. Okay, so that we can do. This is known as partition of the interval. Okay, so with this partition we have subintervals. First subinterval will be x naught to x1. Second subinterval will be x1 to x2, and the nth subinterval will be xn minus 1 to xn. Find the mesh of the partition is defined as the maximum length of the partition. So which means that when you, after picking the points x naught, x1, so on to xn minus 1 and xn, you identify the length of each of the subintervals. So first, the length of the first interval will be x1 minus x naught. Length of the second interval will be x2 minus x1. And length of the nth interval will be xn minus 1. Okay, so we denote these lengths, let's say for the kth interval, by delta k. So delta k is xk minus xk minus 1. Okay, so this is This is known as partition, and the mesh of the partition means you take this, you find the length of the interval, each of the sub intervals, and take the maximum. That is known as the partition. That is known as the mesh of the interval. So you have a partition, and for every partition you have a mesh. Mesh means the maximum size of the subinterval. For the convenience, what we do is we take the equal partitions. That means if I take the mesh of the partition equal to b minus a by n, then this is known as partition of equal lengths. And also when n goes to infinity, that means you include more and more points from the interval, then you get the entire interval. Okay, so the partition becomes more and more finer, and the mesh size approaches to 0. Okay, so basically here you are saying that, let's say I have the interval 0 to 1, and I pick a point 1 by 2. So I have two subintervals. One is from 0 to 1 by 2, another one is from 1 by 2 to 1. So with these two subintervals, I have equal length. Length of the first interval is 1 by 2. Length of the second interval is 1 by 2. Okay, so we have this partition of equal length, and this that is the mesh size of this partition is 1 by 2. Okay, now you choose one point in this first interval and another point in the second interval. So now in the first case we had two subintervals, 0 to 1 by 2 and 1 by 2 to 1. Now we have four subintervals, 0 to 1 by 4, 1 by 4 to 1 by 2, 1 by 2 to 3 by 4, and 3 by 4 to 1 by 4. And the length of each of these subinterval, you can see that the length of each of subinterval is 1 by 4. Okay, fine. So this is known as refinement. In the first interval, in the first partition, we have the interval 0 to 1 by 2, 0 to 1 by 2, and 1 by 2 to 1. In the second partition, we have 0 to 1 by 4, 1 by 4 to 1 by 2, 1 by 2 to 3 by 4, 3 by 4 to 1. So we have more subintervals here. So this is a refinement. The second partition is a refinement of the first one. Okay, now we can refine this further also. Now I can take 1 by 8. I put one more points in each of the subintervals. So this becomes more finer as compared to the first and the second partition. Okay, so that means when n goes to infinity, or you can say that 1 by n goes to 0, 1 by n, when n is equal to 2, then you have the first partition 0 to 1 by 2 and 1 by 2 to 1. When n is equal to 4, you have the second partition 0, 1 by 4, 1 by 4 to 1 by 2, 1 by 2 to 3 by 4, 3 by 2, 4 to 1. Okay, and similarly when similarly you can have n is equal to 3, n is equal to 4, n is equal to 8, and so on. Okay, so that means when n goes to infinity, the partition becomes more and more refined, because the size of this subinterval is becoming more or less as compared to the previous one. Okay, so it becomes finer and finer, and obviously the mesh size will approach to 0. Mesh size is 1 by n, so when n goes to infinity, this will approach to 0. Okay, so you have this thing. Now the second definition is Riemann sum. So Riemann sum, what do we mean by Riemann sum? Let us consider I have a function of one variable. So that means f is a function from R to R. Or for the convenience, we can say that, not for the convenience, we can say that the domain of the function is interval a to b. So f is defined from the interval a to b. And let us say that this is the shape of the function. So what we do is we partition these intervals, partition this interval a to b into subintervals, and in each of the subinterval we have this. Okay, so the length of let's say the length of the kth subinterval is delta xk, and if you look at this kth subinterval, you have this rectangle. Okay, so the let's say you pick one point xk star, you pick a one point xk star in this subinterval and evaluate the value of this function at point xk star. Okay, so which gives you f xk star, and multiply this by the length of the interval, which is delta xk, and sum this over all the subintervals, k varying from 1 to n. Okay, this is known as Riemann sum. This is known as Riemann sum. फाइन. सो इसमें हम क्या कर रहे हैं कि इंटरवल ए और बी है उसका पार्टीशन कर दिए एन सब इंटरवल्स में, और फिर हर सब इंटरवल में एक पॉइंट एक्स, हर सब इंटरवल में एक पॉइंट पिक किए. जैसे फर्स्ट इंटरवल में पॉइंट पिक करेंगे x1 स्टार, सेकेंड इंटरवल में पिक करेंगे x2 स्टार, एथ इंटरवल में होगा xk स्टार, और nth इंटरवल में होगा xn स्टार. अब इस पॉइंट पे फंक्शन का वैल्यू डिफाइंड है, तो उसका वैल्यू हो गया एफ एक्स के स्टार kth इंटरवल के लिए. तो kth इंटरवल वाले में वी हैव मल्टीप्लाइड दिस लेंथ ऑफ द kth इंटरवल एंड देन add everything up from 1 to k. So this you get a sum. This sum is known as Riemann sum. Now we want to study what happens if n goes to infinity. What happens with this Riemann sum when n goes to infinity? N goes to infinity means the length of the subinterval is going towards 0. You see that the length of the subinterval is, if we have equal length of the subinterval is b minus a over n. So when n goes to infinity, the length of the subinterval will go towards 0. Okay, so our aim is to study this. So for this, we give this definition. This is Riemann integral. So it says that when n goes to infinity, Sn will converge to S. This S is known as the integral of the function. So what does it say? The Riemann integral of a real valued function f over the interval a to b is equal to a real number s if Sn is this Riemann sum that we have just constructed. This is our Sn. If Sn converges to S when n goes to infinity, Sn converges to S when n goes to infinity. Now the question is, what do we mean by Sn converges to S when n goes to infinity? What is the meaning of this? And the meaning of this is explained here. That is, for every epsilon positive, there exists n epsilon such that the distance between Sn and S is less than epsilon for all n greater than n epsilon, and you can call this n epsilon as delta. Okay, so what is the meaning of Sn converges to S? The meaning of Sn converges to S is for every epsilon greater than 0, strictly greater than 0, there exists a delta, or you can say n epsilon, such that the value such that the distance between Sn and S is less than epsilon whenever n is greater than delta or n epsilon. Okay, so that means you pick one, एक epsilon choose कर लो और फिर तुम्हें एक n ढूंढना है, so that Sn का और S का डिफरेंस उस epsilon से छोटा होगा जो तुमने चूज किया है, और ये हर epsilon के लिए होल्ड करना चाहिए. अगर हर epsilon के लिए होल्ड कर गया, हर पॉजिटिव epsilon के लिए होल्ड कर गया, so epsilon you take small as possible, you'll always get one n delta, after which the difference is always less than this epsilon, whatever you have chosen. Okay, so this is what we mean by Sn converges to S when n goes to infinity. Okay, and this S, where this Sn converges, this S is our integration of fx over a to b. Fine. Any question? Any question in this part?
Sir,
Yes.
sir, what is that capital N?
Capital N is the, okay. तो सपोज कर लो कि तुमने एक डेल्टा चूज किया 0.05, एप्सिलॉन चूज किया 0.05, ठीक है. अब इस 0.05 के लिए इसका वैल्यू तुमको 0.05 से छोटा बनाना है. तो अब हम बोलेंगे कि ये एक पर्टिकुलर n के बाद, कैपिटल N के बाद इसका वैल्यू इससे छोटा होने लगेगा जो एप्सिलॉन तुमने चूज किया है. तो ये है n, ये कैपिटल N. इज दिस क्लियर और नॉट?
Sir, can we arbitrarily choose the capital N?
या सो अब देखो, अगर यहाँ पे तुम एप्सिलॉन बहुत बड़ा नंबर ले लिए तो n के एक पर्टिकुलर वैल्यू से स्टार्ट हो जाएगा इसका डिफरेंस.
Okay.
तो 100 के लिए जो n मिलेगा वो तुमको अलग मिलेगा, 0.5 के लिए जो n मिलेगा कैपिटल N वो अलग मिलेगा. तो इसी तरीके से हर एप्सिलॉन के लिए तुम्हें एक कैपिटल N ढूंढना है. इसीलिए स्पेसिफिकली यहाँ पे लिखा हुआ है कि जो n है वो एप्सिलॉन पे डिपेंड कर रहा है. सबस्क्रिप्ट में एप्सिलॉन लिखा हुआ है. इज दिस क्लियर?
Okay, sir.
इज इट क्लियर? यस और नो?
Sir.
Yes, sir.
Okay, so basically I am not giving example on this because this is part of a full course on analysis. यहाँ पे analysis हमें discuss नहीं करना है ना, तो बस मैं इसको एक intuitive तरीके से बता के और फिर आगे बढ़ जाऊंगा कि intuitive level पे क्या हो रहा है. ठीक है, इसका अगर मैं प्रूफ करने से लग जाऊं तो ये 2 क्लास में तो इसी का प्रूफ होगा, 2 क्लास से भी ज्यादा लग जाएगा, क्योंकि अपर रेमान सम, लोअर रेमान सम, फिर फर्स्ट ऑफ ऑल यू नीड टू अंडरस्टैंड व्हाट इज द मीनिंग ऑफ कन्वर्जेंस एंड कन्वर्जेंस कैसे शो करते हैं. उसमें बहुत सारे टेस्ट होते हैं. फिर वो कन्वर्जेंस का टॉपिक जब खत्म होगा सीक्वेंस के कन्वर्जेंस का, फिर तुम आओगे रेमान सम पे, फिर वहां पे आओगे तो अपर रेमान सम, लोअर रेमान सम, एंड देन यू विल प्रूव दिस. सो मे बी इट विल टेक 5 lectures, 7 lectures to prove all these things mathematically. Fine. So I'm not going to into that detail, otherwise it will be complicated. it will completely go in a different direction. Okay, so let us consider this example. You want to integrate, now let us take this. So we said that S is this. So we said, let us take my F is the linear function X. Okay. And B is 1, A is 0. So we want to integrate this. Everybody knows how to integrate this. Integral of x dx. The integral of x dx is x squared by 2, and this comes out to be 1 by 2. Okay. So this is what we mean by this integration. So integration का जो theory है वो यही है, Riemann sum को converge कराना under suitable norm. So if you go for further generalization, you will see that you will see that if you go an advanced course on analysis, you will see a lot of advanced topics like Lebesgue integration, integration with respect to measurable. There are several things. I do not want to confuse you. Okay. Now let us go return back to, so all this was related to, all the discussion that we had so far was related to the function of one variable. Now consider a function of two variable. तो function of two variable में क्या होगा, इसका domain क्या होगा? Domain of function will be, let's say domain is denoted by R, which is a subset of R2. Let's say this is my domain R, and this is subset of R2. This is x-axis, this is y-axis. So it says that we cover the region R by a rectangular grid, and the number of rectangles which lie completely inside R as we denote this as A1, A2, AN. ठीक है, तो अब इसके अंदर रेक्टेंगल्स बनाते जाओ. रेक्टेंगल्स कैसे बनाओगे? सबसे आसान तरीका क्या है रेक्टेंगल बनाने का? तो identify this point. You draw a line parallel to x-axis. So that it passes through the region. And then draw a line parallel to y-axis. So that it passes through the region. So all these are rectangles. ये एक rectangle है. This shaded region. Let us pick a different color. This is also a rectangle. Red color and this is also a rectangle. Okay, so you make a rectangle in such a way that this region R is completely inside this rectangle. Okay, so you can choose ठीक है. तो अब यहाँ पे जो बाउंड्री के रेक्टेंगल्स हैं, व्हाट आर दोज रेक्टेंगल्स? ये वाले बाउंड्री के हैं. Okay, so this is how you form the rectangles, by drawing line parallel to x-axis and y-axis, and you create these rectangles in such a way that the region R, which is the domain of the function, or the domain of integration, you can say, if you like to say it is domain of integration. So this R should be completely inside these rectangles. Okay. And let us denote these rectangles by A1, A2, and so on to AN. Denote these rectangles as A1, A2, so on to AN. तो यहाँ पे क्या किए थे? वन वेरिएबल वाले केस में, वन वेरिएबल का वाले केस में जो पॉइंट दिया हुआ था हमारा A to B, जिसके ओवर इंटीग्रेट करना था, उसमें से हम पॉइंट्स पिक किए थे, ठीक है, ताकि पूरा सब इंटरवल्स क्रिएट करें और सब इंटरवल्स का अगर यूनियन ले तो वो पूरे इंटरवल को कवर कर ले। तो अब यहाँ पे उसी को एक्सटेंड कर रहे हैं 2 डायमेंशन में। अब 2 डायमेंशन में सब इंटरवल्स नहीं रहेगा, रेक्टेंगल्स आ जाएंगे। 3 डायमेंशन में रेक्टेंगल्स नहीं रहेगा, वी विल गेट cube, something cube, rectangular, what is the name?
Cuboid.
Cuboid, you can say, yes. Okay, so this is how you create. So so it may happen that in this may be the reason of integration. तो यहाँ पे जो पैरेलल जो लाइन प्लॉट कर रहे हैं, वो लाइन इस तरीके से प्लॉट कर रहे हैं कि तुम्हें पूरा रीजन कवर होना चाहिए। तो ये सारे रेक्टेंगल्स तुम्हारे काउंट होंगे। इसमें से कुछ जो है वो रेक्टेंगल्स के अंदर का पोर्शन है और कुछ जो है वो रेक्टेंगल के बाहर का पोर्शन है, ठीक है। सो इस तरीके से रेक्टेंगल्स बना लिया हमने, एंड देन वी इसको नंबरिंग कर दिए कि रेक्टेंगल A1 है, रेक्टेंगल A2 है, रेक्टेंगल A3 है, रेक्टेंगल A4 एंड सो ऑन AN है। अब हर रेक्टेंगल का एरिया निकाल सकते हैं। इसमें क्या किए थे, 1 वेरिएबल वाले में हर सब इंटरवल्स में एक लेंथ निकाले थे, हर सब इंटरवल्स का लेंथ, एंड kth इंटरवल लेंथ ऑफ द kth इंटरवल was denoted by delta k, ठीक है। So in the same way we will find the area of this rectangle, and when you go to 3-dimensional the function of 3 variable case, तो क्यूबाइड का एरिया निकालेंगे। ओके, so let us say that delta ak denote the area of the rectangle in this case, and area of the rectangle will be length into width. So let us say that when you draw the line parallel to x-axis, ये रीजन था, ठीक है, parallel to y-axis, these are the lines parallel to y-axis. So these lines are drawn at the same distance, delta x. The distance between these two lines are delta x, similar to what we have done here. Distance of each of the sub-interval is delta x, okay, which is equal to b minus a by n, ठीक है, इक्वल लेंथ का कर रहे हैं तो। So in the same way we write delta और इसके बाद जो y एक्सिस के correspond के पैरेलल, x एक्सिस के पैरेलल जो लाइन ड्रॉ की है, उसमें जो हर लाइन का डिस्टेंस है, that we say that this is delta y. Okay, so this means that the width of each of these rectangles will be the area of each of the rectangle will be delta x into delta y, width into length, ठीक है। width सपोज डेल्टा x है और लेंथ सपोज डेल्टा y है, तो दोनों को मल्टीप्लाई कर दिए तो एरिया, फाइन। सो दिस वी डिनोट बाय डेल्टा ak। अब नेक्स्ट पीछे क्या किया था हमने, in one variable case in each of the sub intervals we picked a point x star. So in kth sub interval the point is, in the kth sub interval the point is xk star, okay। तो अब इसमें क्या है, रेक्टेंगल के अंदर पॉइंट लेना पड़ेगा, वहां पे सब इंटरवल्स के अंदर पॉइंट लिए थे, तो here we will take the point inside the rectangle. So let us say that the point inside the rectangle is xk star and yk star, ठीक है। अब इसमें रेमान सम पहले कैसे निकाले थे, वैल्यू ऑफ द फंक्शन at point xk star, where xk star is a point inside the kth sub interval, times the length of the sub interval, length of the kth subinterval. So in the same way, we will do this. We pick a point xk star, yk star in the kth rectangle. So we have the function at point xk star, yk star times वहां पे लेंथ था, यहाँ पे एरिया हो जाएगा. ठीक है. So area will be delta ak. Hey. Is it okay?
Hello, sir.
So then you sum everything. So that gives you the Riemann summation. Yes.
Sir, there are still many functions that are not integrable.
Those functions are not considered here. Only those functions which are integrable. So you see that we started with f is a continuous function.
Yes, sir.
Okay. But it does not mean that only continuous functions are integrable. Even if the function is not continuous, you can still find the integration.
Yes, sir. But also, even if the function is continuous, sometimes we cannot find how to integrate it well in one dimension also.
No. For continuous function integration, you cannot find the explicit value, you can say, but integration will exist.
Yes, sir. So, if we cannot find explicit value, sir, so can we change the rectangular grid to something else?
No. It will give you the same thing. The reason is that you can choose any shape. This is a good question. Here we have taken the rectangular shape, and this
Yes,
is
sir.
done
So, if
for,
it is not integrating,
this is done for mathematical simplicity, because you know how to find the area of the rectangle. If you take any other shape, that will also work. But only thing you can say that we can integrate this function. But what is the value of the integration? You may not calculate explicitly.
even if we do not take rectangles and take some other shape, then
Yes,
also.
you cannot. Yes.
Okay, sir.
Okay. Because these rectangles are done to fill the region of integration. So you fill by the rectangular shape or some other shape. It really does not matter. Okay, still you will not be able to find.
Okay, sir.
Fine.
Yes, sir.
Okay, so now we have this Riemann summation. Now we say that when n goes to infinity, and what happens when n goes to infinity? We have more and more rectangles. We have n rectangles at this moment. When you take n goes to infinity, we have more rectangles. More rectangles means we have to put more lines parallel to x and y axis. तभी तो ज़्यादा rectangles बनेंगे. When we put more and more lines parallel to x and y axis, this means you are refining your partition. जैसे पिछले वाले केस में इंटरवल्स को पार्टीशन किए और फिर उसमें जो सब इंटरवल्स आए उसके अंदर भी पॉइंट्स ढूंढ के फिर से पार्टीशन किए उसको, तो वो रिफाइनमेंट हो गया. तो यहाँ भी वैसे ही है, फर्दर उसको रिफाइन कर रहा है. So when n goes to infinity, your partition of the region of integration becomes more and more refined, and you can expect the convergence of the sequence Sn. Okay, and then what is the meaning of this convergence? When n goes to infinity, Sn will go to S, Sn will converge to S, and again the same meaning, exactly the same meaning that we have written here. The meaning of Sn converges to S when n goes to infinity. There exists, for every epsilon, there exists an epsilon such that Sn minus S is less than epsilon whenever n is greater than n epsilon. Okay? So that is the meaning. And this S that you get, will be now the double integral of f. वहां पे सिंगल इंटीग्रल था, यहाँ डबल इंटीग्रल, तो ये नोटेशन इसका दे दिया यहाँ. Is it clear?
Yes, sir.
Now यही प्रोसेस हमें दूसरे केसेस में भी अप्लाई करने हैं. ट्रिपल इंटीग्रल में भी यही अब प्रोसेस अप्लाई करने हैं. फिर डबल इंटीग्रल में I said in last class that any point, last class में बोला था मैंने, yeah, in the beginning of this, in the last class I said that in double integral you can represent a point in the rectangle with the rectangular coordinate, and you can also represent a point. So in R2 you can represent a point either in rectangular coordinate or in polar coordinate. या तो बोलो x1 x2 है, और या उसको r and theta के टर्म्स में रिप्रेजेंट कर दो. So if you represent the point in x with rectangular coordinates, then you get this integration that we have just seen. Okay. पोलर कोऑर्डिनेट में भी सेम चीज करना है. अब वहां पे पार्टीशन पोलर के अकॉर्डिंग पार्टीशन होगा. पोलर में कितने पैरामीटर्स होते हैं? एक होता है रेडियस, एक होता है थीटा. रेडियस एंड थीटा. So now you have to, what is so basically I'm trying to connect everything in the same lectures. All these things are written on the slides and on future slides, but you can still, so this is, you can still try to understand what I'm trying to say. So here if you have this point is represented by xy, and if you represent by xy, then you work with this partition. This is the way of partitioning the region. Now instead of representing the point xy, if you represent the point by the radius r and the angle theta, so this is r theta. ठीक है? And what is r theta? R theta is this circle, radius of this circle. तो अब इसमें पार्टीशन कैसे करेंगे? रेडियस और थीटा का पार्टीशन यहाँ से निकालते जाएंगे. रेडियस से एंगल का पार्टीशन ऐसे होता जाएगा. अलग अलग एंगल प्लॉट करते जाओ और रेडियस, अलग अलग रेडियस प्लॉट करते जाओ. ये सब पैरेलल होगा. आई थिंक मेरा थोड़ा राइटिंग सही नहीं है. ये सारे लाइंस पैरेलल होंगे. ऐसे ऐसे रेडियस, अलग अलग रेडियस पे सर्कल ड्रॉ करते जाओ. तो अब यहाँ पे you can see that you are getting this polar rectangle. All these are polar rectangles. Whatever I am filling with blue, these are polar rectangles. Okay, so here you had this rectangular shape. The area of this rectangular shape was delta x delta y. वहां पे पोलर रेक्टेंगुलर का एरिया निकालना होगा और फिर डबल इंटीग्रेशन करना होगा सेम तरीके से. फिर पोलर रेक्टेंगल के अंदर एक पॉइंट ढूंढेंगे. जैसे यहाँ पे एक्स स्टार वाई स्टार ढूंढे केथ रेक्टेंगल के अंदर, उसी तरीके से केथ पोलर रेक्टेंगल के अंदर एक पॉइंट ढूंढेंगे. वो पॉइंट कैसे रिप्रेजेंट होगा? वो पॉइंट रिप्रेजेंट होगा आर के कॉमा थीटा के. आर थीटा से पॉइंट रिप्रेजेंट कर रहे हैं ना. सो आर के कॉमा आर के स्टार कॉमा थीटा के स्टार. ठीक है. एंड देन you again construct the Riemann sum, and then you take the limit. The sense of this limit, the sense of this limit Sn converges to S will be same for all the cases. केवल उसमें एरिया चेंज होते जाएगा. ठीक है. So that will give you the double integral in polar form. Now you can do the same thing in for function of three variables. First, for function of three variables, a point in R3. First of all, you have to identify a point in R3. Now, to represent this point in R3, you have three options. One is the rectangular coordinate, one is the cylindrical coordinate, and the other one is spherical coordinate. Okay. So in the same way, you will construct three types of integral. Using the rectangular coordinate, you have one in triple integral. Using the cylindrical coordinate, you have a triple integral, and using the spherical coordinate, you have triple integral. Now in the rectangular coordinate, you have three axes, x, y, and z. So in rectangular region, just like this two-dimensional case, we will plot lines parallel to x-axis, lines parallel to y-axis, and lines parallel to z-axis. So you will have cuboid there. Okay. So you can find the area of the cuboid, which will be delta x into delta y into delta z. These lines will be drawn at the same length. Okay. So the area will be delta x, delta y, delta z. Now, if you go to cylindrical coordinate, then you have to partition this in the cylindrical coordinate way. When you go to spherical coordinates, you have to partition this in spherical coordinate way. Okay, so all these things are already explained on this slide. So I'll show what we have. What I'm referring to is this. So as I said, this was this in R2. Reason R was in R2 and this is in polar coordinate. यहाँ पे है ना, अभी मैंने बताया कि अलग अलग एंगल पे ड्रॉ करते जाओ और ये जो सर्कल्स है वो अलग अलग रेडियस पे है. ठीक है. अब जो तुम्हारे पास what you have got is the polar rectangle. So polar rectangle is denoted by this. You find the area of this polar rectangle. This area will come out to be this. These are already explained on the slides. And then you construct the Riemann sum. Right? So here this delta AK will be replaced by this new area. That's the only change. And obviously x and y will be replaced by r and theta. So that gives you the double integral in rectangular form. And then when we learn this triple integral, then as I said, we have this. So I said area, not it will be volume, not area. So delta V, volume will be delta x, delta y, delta z. If you represent the point in the rectangular coordinate, and if you do the same with cylindrical coordinate, so this is how you represent this point in cylindrical coordinate. So you see that you have a cylinder here. Okay. So first of all, you measure the height of the cylinder, which is, let's say, Z. This is the point I'm referring to. Let me use some different color. This is the point I'm referring to. So this is the height of the cylinder, and then you project this point in the XY plane. So that will give you some angle with the x-axis as theta, and the radius will be r. So points will be r, theta, and the height of the cylinder z. ठीक है. तो r थीटा में पार्टीशन पता ही है, z में पार्टीशन पता ही है. z में कैसे करते हैं पार्टीशन? z तो रेक्टेंगुलर कोऑर्डिनेट का पार्ट हो गया, तो डेल्टा z के लेंथ पे प्लेन्स डालते जाएंगे जो एक्स वाई प्लेन के पैरेलल होगा. ठीक है. आर थीटा का पार्टीशन अभी हमने देखा. आर थीटा का पार्टीशन क्या था? सर्कल्स ड्रॉ करते जाओ और डिफरेंट एंगल्स ड्रॉ करते जाओ. This was this r theta partition. So that gives you the cylindrical. So you calculate the cylindrical volume. Calculate the cylindrical volume. So there are procedures for calculating the cylindrical volume, and this will ultimately come out to be this. This will come out. Oh, कौन सा color choose हो रहा है? This will come out to be this. Okay. And फिर से वही चीज, we will take a point in this in this case we take some point. This point is, let's say, rk, theta k, z, and then accordingly we can construct the Riemann sum, and then we say that this Sn converges to S when when n goes to infinity. You get the triple integral in cylindrical coordinate. And you can also do the same process you can do in spherical coordinate. So here we have spheric points represented in spherical coordinates. So for that you pick, let's say this is the point. Let me use a different color which you can see. So you have this point. Can you see my pen? This point. So this point, you can say that this point makes an angle phi with z axis, and you project this point in the xy plane. Draw this red line here. This will make certain angle with theta, certain angle theta with the x-axis, and the radius is r. Okay, so you have 3 parameters. The radius is rho. Here we are denoting radius by rho. So rho, theta, and phi. Okay, so accordingly you have to do the partition. Now, when angle with the x-axis is phi, you get this cone. The cone is represented by this blue shape. Okay. When angle is theta, you get a plane, which is represented by this. You see that this is the angle theta. Okay. So in that way, you have to like basically understand how the points are represented in these coordinates, and then accordingly you make the partition. So after partition, you will get these types of blocks. Okay, so you find the area of this block. Volume of this block. This volume will come out to be this, and again construct the Riemann sum in the same way. And this will converge to some number S. Again, the notion of convergence is same that we have seen before. And this gives you the triple integral in the spherical coordinate. Okay, so this is the intuitive idea of these integrals. Is it fine? Any
Yes,
question?
sir. Sir, one doubt I had.
Yeah.
Sir, theta and phi here represent angles from which axis?
Phi represent angle with a z-axis, so you get a cone. क्योंकि उसको घुमा सकते हो ना पूरा चारों तरफ.
Yes, sir.
Okay, and theta represents the angle with the x-axis of the projected point.
Sir, it
So
is.
if you,
Sir, physics has a different convention, right?
what?
Sir, in physics, I think theta is from z-axis and phi is from x.
Okay, the real does not matter. Whatever notation you want to use. I don't.
Okay.
I have done the same thing, or
Yes, sir. I got this idea.
okay. So main thing here was to explain the idea how the integral will be defined. ठीक है? So
Yes,
that
sir.
my objective was to give you the intuitive idea of geometrically of how the double and the triple integrals are defined. Double integrals in rectangular and polar coordinate, triple integral in rectangular, cylindrical, and spherical coordinates. ठीक है, यही सारी चीजें हैं यहाँ. These are the things that we are going to see. So this is the basic intuition, basic geometrical idea. Mathematical detail is not easy. It's beyond the scope of this book. What is the difficulty here? In mathematically, to prove Sn converges to S. That is the difficulty. Sn converges to S. The definition I have given you in the beginning. The difficulty here is to prove this. In all these cases, 5 तरह के इंटीग्रल्स मैंने बता दिए ना. डबल इंटीग्रल with rectangular, double integral in polar, triple integral in rectangular, triple integral in cylindrical, and triple integral in spherical. So in all these cases, when you construct the Riemann sum, constructing Riemann sum is not difficult. How the construction of Riemann sum is already given on the slide. The difficult part is to prove Sn converges to S when n goes to infinity. That means the difficult part is to prove that for every epsilon there is an epsilon such that mod Sn minus S is less than epsilon for all n greater than n epsilon. Okay? तो अगर कोई अगर तुम लोगों में से कोई अगर एनालिसिस का कोर्स लेगा अगर फ्यूचर में, तो ये सारी चीजें मैथमेटिकली कैसे प्रूव करते हैं वो तुम वहां सीखोगे. ठीक है? एंड इट इज नॉट स्ट्रेट फॉरवर्ड. तो ये थोड़ा एडवांस लेवल का मैथमेटिक्स आना चाहिए तभी कर पाओगे. इज इट क्लियर?
फिजिक्स ब्रांच को मिलता है ऑप्शन?
आई थिंक इट शुड बी.
Okay, sir.
I don't see any problem in having this one extra course there. Is it okay? Shall I move? If you have any question and further discussion, that is also fine. The time is already up also. That is also the case. Couple of minutes are left. So what I do is I should stop here. And if you have any question, I can ask. I can entertain that questions. Rest of the things. तो अब तो हमारा फोकस क्या होगा? दैट इज ऑल्सो मैं ये भी बता देता हूँ. फोकस होगा यहाँ पे. जितने भी 5 इंटीग्रेशन है उसमें फोकस यही है. प्रोसीजर फॉर फाइंडिंग द लिमिट्स ऑफ इंटीग्रेशन. व्हेन यू गो टू double integral in polar coordinate, there also this is our focus. When you go to triple integral in rectangular coordinate, then you see this is our focus. And when you go to triple integral in cylindrical coordinate, this is our focus. कितने हो गए? 3 हो गए, 4 हो गए. And when you go to spherical coordinates, this is our focus. ठीक है? तो पूरे चैप्टर में, इन द इंटायर चैप्टर, यू हैव टू मेनली फोकस ऑन दीज 5 स्लाइड्स. ठीक है? अगर ये 5 स्लाइड्स तुम्हें अच्छे से समझ आ गया तो डबल ट्रिपल इंटीग्रल के सारे क्वेश्चंस कर लोगे. ओके? और कुछ नहीं रहता है इसमें. और फिर एक जैकोबियन तो चलो वो तुमने किया ही हुआ है. चेंज ऑफ वेरिएबल थोड़ा बहुत है. बीटा गामा तो नया टॉपिक है. ठीक है? तो डबल इंटीग्रल, डबल एंड ट्रिपल इंटीग्रल में ये 5 स्टेप्स अगर तुम्हें पता है तो तुम समझो कि ये चैप्टर कंप्लीट हो गया. These are the 5 important slides. Is it okay?
Yes, sir.
Sir, and I had a doubt in previous slide of last class. One doubt.
Yes.
Sir, in R and theta curve tracing. Sir, in that how we arrived at that graph result.
Which one?
R and theta. The next one. Next.
Which one?
Yes, sir. This one.
ये
Next.
तो is this one. This one.
Yes, yes. This one. How we came to the graph conclusion analytically.
Basically, you just in this type of problems in the polar coordinate, I think if you just take different values of theta, evaluate the value of the function at different values, and maintain the continuity of the function, then you get.
Sir, but
Here we have symmetricity also, because this is r square plus 4 2 cos theta. Okay, so you just plot this one, and the remaining will be the mirror image of the first one. So you just plot this one, this portion, and the remaining is the mirror image. And for the first portion, you take different values of theta, calculate. यहाँ तो 3 वैल्यू लिए, 3 से ज़्यादा भी ले सकते हो, थोड़ा प्रैक्टिस होने के बाद you will be able to see only couple of values will give you the result, and then calculate the value of
sir,
r.
like we check concavity and increasing, decreasing here, we cannot check like that.
That you can check by taking the values also. You should
Sir,
not
your voice is cracking, please.
just that you can check by taking the values also. So for polar coordinate, we have different rules. Where is that? I have written that on this slide. So these are the rules for polar coordinates. So here,
Yes, sir, but
here.
sir, I have read these rules, but I did not get how to analyze the curve like we did in second derivative, first derivative.
No derivative is involved here.
Yes, sir. So I was asking how we can analyze, but values is the only
here,
option.
in polar coordinate, you just put different points and then plot the curve. Okay.
Yes, sir.
That is, and maybe you then after plotting the curve, you may look at these points, these steps, whether these steps are satisfied or not.
Sir, or can we write r as square root x square plus y square or anything like that?
Sorry.
Can we write r as square root of x square plus y square?
You can write it. You can convert this to the rectangular coordinate. No problem with that. And then apply the rectangular coordinate procedure to trace the curve.
And for theta, what we use? Tan inverse.
Yes, tan inverse y by x.
Okay, sir. Thank
Fine.
you.
But
Yes.
usually the polar coordinate is used when it is difficult to apply
Okay, good afternoon, everyone.
Good afternoon, sir.
All right. Good afternoon.
Good afternoon.
All right, so yeah, good afternoon, everyone, again. All right, so my name is Sumanta Sarkhel, and I'll be teaching you today and then Friday, right? Friday I think on 5 to 6. Am I right?
Yes, sir.
Yes, sir.
All right, so this is the class for, I mean, it is not a specific class as you are going through it. I'm sure you are reading that. So this one is for, I mean, in the department, what we normally do the research actually that we are giving you the flavor. Okay. So my research of flavor, I mean, topic is basically atmospheric and space physics. So we do the research on atmosphere and near Earth space. Okay. So as you know, nowadays there are a lot of opportunity in space technology, space science area, right? And probably you may be knowing that one of the IIT Kanpur has already opened a department in space science and astronomy part. Okay, in the department. So there are a lot of opportunity if you go for a PhD, if you go for a job. So there are a lot of opportunity for, and as you know, that there are a lot of new startups are coming in space industry, space research, or you can say the industry for making rockets, satellites, and so on, so many things. Okay, so there are a lot of opportunity if you go for if you want to stick to a PhD, or if you go for a normal job. So that is, many things are possible. Those who are in integrated MSc or in engineering physics, anyway, it doesn't matter. Okay, so. And of course, it matters. The only thing, there's another thing is matters is that what is your liking. So that is very important. Okay. So if you are fascinated with something, some subject, and of course, you have to also see that whether how the opportunity will come if you are fascinated with some subject. Okay. Whether is there an opportunity or not, because eventually you get a job, right? Eventually, after PhD, also you need to get a job somewhere else. I mean, it may be in academic area or maybe in research and development area, anywhere. So eventually you have to see that what are the opportunities. So there are a lot of opportunities in this area. So that is why we see, and above that, like you know that in this last year in 2021, the Nobel Prize in Physics was given to a climate scientist, right? And it, of course, it was shared. So one share went to the climate physics. Okay? So it is related to the atmospheric physics core, basically. Okay? Nothing else. So those who are doing climate, it's basically you're dealing with atmospheric processes and so on. Okay, so that's why this field I will going to give you a glimpse of it. Of course, I cannot give everything in 2 classes, but I'll give you the glimpse of it. Okay, so try to listen very carefully. Okay, and of course you ask questions if you have any time in your mind. So don't record the lecture. I don't like recording lectures. But if you have any problems, let me know. Try to note down things. Okay. So that is one thing from my side. All right. So let us start. I'll share one slide. And it is very important, but at the same time, extremely knowledgeable if you have anything related to this. All right. Let me pointer option. Okay. All right, so if you can see that, I mean, this is a slide of the whole atmosphere. Okay, and if you see that in the vertical axis, we have plotted altitude. So normally in atmospheric physics, we plot altitude in the vertical axis just to show, just to visualize that altitude also varies vertically, right? If you go vertically means you are gaining altitude. So that is why in every parameters you can basically altitude, I mean, whenever there is a change in the altitude, and there will be change in parameters basically, and this one is basically plotted in vertical axis. Now, so how this Earth atmosphere means, what do you mean by Earth atmosphere? Right? So Earth atmosphere is means, so I told to don't don't record the lecture. So please, those who are not listening, can you don't record the lecture, please? All right. So please don't record the lecture. So try to listen it properly. Okay. You take a note of whatever I say as much as possible. Okay. And the questions will be from there itself. Okay. So don't record the lecture. All right. So the thing is, Earth atmosphere can be divided into few layers, right? Troposphere, then stratosphere, then mesosphere, thermosphere, and so on. And Earth atmosphere also has plasma content, or electrons or ions basically. So that is called ionosphere. That we'll deal later on Friday. Okay. So in general, you see that atmosphere can be divided based on the temperature, the variation of temperature. Basically, you see, this is in the x-axis, we have plotted temperature, and in the y-axis, it is, as I told, it is altitude. And at different places, you see that how it looks like. I mean, you see, in the troposphere means there is in the troposphere we have a ground over here, and then all the mountains, and troposphere is up to like 15 kilometers or so. And then there is called stratosphere, then there is called mesosphere, and you see in the region where in the thermosphere called, we have international space stations, then the space shuttles, these actually stations in that region, 400 kilometers region. All right, so in the thermosphere or in the ionosphere, whatever you call it. All right, so now we have to understand why the temperature actually varies like this. So that is what we have to understand. You see, in the troposphere it is decreasing, then in the stratosphere it is increasing, in the mesosphere it is again decreasing, and in the thermosphere it is increasing, and eventually it becomes constant with altitude. Okay, eventually it becomes constant. It doesn't change with altitude. Okay. So that is what we are going to. I'm going to give you a glimpse of it. How, why, in the troposphere, temperature decreases with altitude. Okay. So why now? We'll just see. So everything now is controlled by sun. Okay. So all this is the temperature, this ionosphere. These are all because of sun, solar radiations, either from electromagnetic radiations or charged particles as well. So both these things are coming from sun. So intergalactic cosmic rays are different. It is coming from outer space, from outer solar system, you can call it. This auroral particles means it is coming from sun only. Solar protons is coming from sun only. Okay, and the radiations in terms of like gamma rays, X-rays, extreme ultraviolet, then ultraviolet, visible, infrared, radio waves, and so on. These are all coming from sun only. Okay. And you see, at different parts of the atmosphere, these rays, all these charged particles, these are getting absorbed, and these absorbed constituents only. All right, because these anyway, it is harmful to human life or any living species. It may be plants, it may be animals, anyway. Any living species, these are not good for them. If suddenly atmosphere vanishes, everything will come to the ground and kill us. Instantaneously we will be killed if suddenly the atmosphere disappears. All right. So the atmosphere basically has primarily nitrogen. Then nitrogen is like 78%. Oxygen is like 21%, and the rest 1% is all other gases: carbon dioxide, water vapor, hydroxyl molecules, and so on, many things, ozone, so many things. Okay, so primarily it has nitrogen, 78%, as you know. Okay, and the density of the atmosphere, basically, it decreases exponentially with altitude. Okay, so it basically decreases exponentially with altitude. Okay? The atmosphere decreases exponentially with altitude. Okay, but the temperature, it is not. It has a zigzag pattern like that. All right. So now in the troposphere, if you go up and up, you see this temperature decreases. I mean, in the summer, if you go to the hill stations, you'll feel cool, right? So the reason is the sun, the solar radiations, it comes through it and it hits the ground and this ground becomes now a secondary heat source, because some of the radiations it comes through, but most of the infrared and visible light, they penetrate the atmosphere and reach the surface of the Earth. And it hits it continuously, the daytime it continuously keep on hitting the surface and becomes the it heats up the surface section. Okay, and that is why if you go away from the surface heat, secondary heat source, you feel cool, right? So the way, during the winter, right? If you have a heater in front of you, so if you go closer to that, you will feel warm. The temperature is more. If you go away from the heater, you will be feeling cold. The temperature reduces, right? There is a gradient. So the same way happens here. Okay. So the sun radiations actually hits up the ground through the infrared radiations, the heat basically, and the ground becomes the secondary heat source. And if you go up in the altitude, obviously you are going away from the secondary heat source and you will feel cool. So that is the reason temperature decreases with altitude, okay, in the troposphere. And at some point of time, it going to turning to the increasing mode. And the turning, it is called pause, the tropopause. All right. And you see in the stratosphere where the temperature increases with altitude. So up to this portion where the temperature decreases, it's called troposphere. All right. And the tropopause means the region where temperature starts increasing mode, going in increasing mode. So far, any questions? Any questions? All right. So in the stratosphere, there is a presence of ozone molecules. Okay. And because of these ozone molecules, what happens? Ozone can absorb these UV radiations. Okay. Although it is not drawn properly, it should come a little bit down actually. But anyway. So these ozone molecules absorbs UV radiations, okay, and decomposes or dissociates. Okay. O3 absorbs UV radiations and dissociates with oxygen molecules and oxygen atom. Okay. O3 dissociates in the presence of UV light with, two oxygen molecules and oxygen atom. And this oxygen atom, as you know, is very reactive. So again, it quickly recombines with oxygen molecules and gives the ozone molecules again. So in this cycle, what happens? This UV radiations actually getting used up. So basically, ozone absorbs it, dissociates it, and again, oxygen atom quickly recombines with oxygen molecules and form ozone molecules again. So ozone basically restored. It is a cycle, complete cycle. And since energy is basically absorbed, that means some form of energy will be there. So energy cannot be like destroyed or created. It only can change its form. So this ultraviolet, like the photon basically, UV photon from the sun, so it basically changes, like it absorbs, and all this absorption actually transforms. So one portion of the energy goes the breaking the bond, ozone bond, and another form goes for increasing the kinetic energy of all the molecules and atoms. in the stratosphere. So that is the reason this stratospheric temperature increases with altitude. At some point of time, it increases, keep on increasing. All right. So if there is a ozone, the density is quite high there in the ozone, in the stratosphere, and the stratosphere, what it does, the ozone molecules absorbs UV radiations. Okay, and some part of the UV radiations used up to breaking the bond of the ozone and becomes O2 and oxygen atoms, and oxygen atom quickly recombines with oxygen molecules to form ozone again, so it completes the cycle. So one part of the UV rays, UV photons, actually UV photon energy, it used up for breaking the bond of ozone, and another part is used for the increase to, I mean, it is used to increase the kinetic energy of the molecules and atoms. So that is the reason the temperature, basically temperature is nothing but the average kinetic energy of molecules and atoms, right? So that is the reason the temperature increases in the stratosphere. All right, any questions?
Sir, I wanted to say that you mean that the radiations are absorbed by the ozone molecule. So that's why kinetic energy increases. That's why the temperature is increased.
Yes.
Okay, sir. Thank you.
Okay. So that is why, I mean, you see, in the troposphere, what happens? Temperature decreases with altitude because you are going away from the secondary heat source, which is the ground. At some point of time, because of ozone heating in the stratosphere, this ozone heating actually takes care of it. It's now surpassed it actually. I mean, there are so much of ozone heating, because of that temperature starts increasing. Although we are going away from the secondary heat source, but still there are so much of ozone heating because of this ultraviolet absorption of UV radiations by the ozone molecules, and this huge amount of kinetic energy of these whole molecules and atoms are increased, and that is the reason temperature also increased because of that. So if there is a change or there is an increase in the average kinetic energy, that means the temperature actually increases. All right. So, but again, it cannot increase indefinitely because there is a ozone above some particular region, okay, above 50 kilometers, the ozone densities are not there, okay. But the ozone, the lack of ozone, and there is part where temperature again decreases. And this part is called mesosphere. And this part, because of lack of ozone heating, and there are cooling agents present in there, in the atmosphere, in this region, it's called mesosphere, where temperature again decreases with altitude. All right. So because of lack of ozone and presence of cooling agent, that helps again to reduce the temperature with altitude. It decreases the temperature, decreases with altitude. Okay. In the troposphere, decrease is just because we are going away from the secondary heat source. But in the mesosphere, it decreases because due to the lack of ozone and in the presence of cooling agent. These are cooling agents are carbon dioxide and OH, hydroxyl molecules. What they do, how they act as a cooling agent. So now we are going to explain that. So what they do, they radiate some radiations, infrared radiations. They automatically continuously keep on radiating. Okay, infrared radiations. Okay, a red line, or sometimes mostly the infrared actually, or near infrared I should say, call it. OH and CO2 keep on radiating near infrared and thermal, so on. Okay, and how this radiation comes? So at the cost of their kinetic energy. So basically, the kinetic energy of these molecules and atoms, these are getting converted into the photon energy, and we are getting the radiations. So if you record, we'll see you keep on. There is some keep on radiations that are coming from the atmosphere, from mostly from the mesosphere. All right, and just opposite to the stratosphere. The stratosphere, what happens? The radiation is absorbed and the kinetic energy is increased. But here in the mesosphere, we are getting the radiations, okay, and the kinetic energy is reduced. All right, that is the reason the kinetic energy is reduced, means the temperature is also reduced. Any questions?
Sir.
Yeah.
Sir, as far as I know, the ground radiates infrared radiation, right?
That is different thing. That is because it is the secondary radiations from the sun. I mean, what happens? Sun radiates so many things, and the visible and infrared radiation hits the ground, and there is a kind of reflections, you can call it, okay, or absorption, then they re-radiates. So that is different thing. I'm telling the radiations is by the molecules, okay, CO2 molecules and OH molecules primarily.
Means
okay.
This IR from the ground does not reach that mesosphere, means they are absorbed in the stratospheric or tropospheric layer.
They may absorb. There's some radiations also leaves and go to the outer space as well. But that is different thing, different types of radiations that is coming from the ground. I am telling these radiations originates within the mesosphere. All right.
Okay, means I wanted to know if that carbon dioxide in the mesosphere were energized by this IR or not.
Well, it may be. It depends actually. It may be. There is a mixture actually. Sometimes it is difficult to tell. Yes, you are correct actually. There can be interactions within that, but the amount, you see, what happens many times these IR radiations are getting trapped within mostly in the troposphere. Some do actually leaves it. Again, the atmosphere, I mean, sometimes they leaves actually, to be very honest, but mostly they are getting trapped inside the troposphere because of greenhouse gases, water vapor, CO2 also acts as a greenhouse gases in the troposphere. See, they absorbs it, okay, but in the mesosphere they radiate it. Okay, so this sometimes it behaves like completely opposite. So in the troposphere also we get the CO2, right? You know, and CO2, SO2, and so other greenhouse gases, they absorbs mostly this IR radiations. Some radiations, of course, they manage to escape and goes to outer space. Meanwhile, they also interact with these molecules as well. All right.
Okay, sir.
Yeah. Any other questions? Anything else? All right. So again, what happens? This temperature keep on decreasing, as I told, in the mesosphere, because there is lack of ozone heating and there is a presence of cooling agent, CO2 and SO2. So it is called the CO2 and not SO2, I'm sorry, CO2 and OH, hydroxyl molecules. These are called basically radiative cooling. The mechanism is called radiative cooling. In the stratosphere, the mechanism is called ozone heating, and because it absorbs the radiations and heats up. In the opposite thing happens in the mesosphere, the radiation comes and it cools up. So it's called radiative cooling process. All right. So if I say that what process actually caused the decrease in the mesospheric temperature? So your answer will be radiative cooling method, cooling process. Radiative cooling process is responsible for the decrease in the mesosphere, temperature in the mesosphere. And similar way, what process actually caused the heating up in the stratosphere? Your answer will be ozone heating. UV ozone heating due to UV, I mean by the UV radiations actually absorbed by the ozone, and this ozone heating is responsible for that. All right. And you see again the temperature, you see the curve again turns and again increases without a change. Okay. Here, can somebody guess that why again the temperature increases in the thermosphere? After mesosphere, why there is an increase in the temperature in the thermosphere? Can somebody guess? Yeah, you can guess. I mean, don't feel shy. It may be wrong answer, fine, but at least you should try.
Sir, because it is exposed and the sun's heat comes directly to the thermosphere.
Yes, but actually, this is, you see, as I told, the density is very, very low, right? If the density is huge amount of density, yes, there is a huge amount of exposure, the absorptions. Yes, there is an absorptions, but a similar way in the stratosphere, there is an absorptions of gas, I mean radiations as well. Okay, so not necessarily that radius actually it absorbs it everywhere. You see, in the mesosphere, it does. I mean, it is not absorbed actually. It doesn't absorb much in the mesosphere. If it is absorbed, then of course there is a increase in relative temperature. So it depends on what type of atoms and molecules are present in that particular region. They helps in absorbing. So you see, in the stratosphere, ozones are there, and they absorb it. They can absorb the UV radiations and helps to increase the temperature. So in the thermosphere, a similar agent is called oxygen atom, and there are other molecules as well. Okay? Oxygen molecules, oxygen atoms. Okay, there are other types of molecules. So they absorb extreme ultraviolet. This one, extreme EUV. Okay, just like in the stratosphere, ozone actually absorbs UV. So in the mesosphere, above mesosphere, or in the thermosphere, it absorbs EUV, extreme ultraviolet. Means it is the wavelength is less than 300 nanometer, okay, or 3000 angstrom, you can call it. UV means it is less than 400 nanometer or 4000 angstrom. Extreme ultraviolet means it is less than 300 nanometer or 3000 angstroms. Okay, so these radiations actually is getting absorbed in the thermospheric region and X-ray as well. So actually, this is probably it is properly not drawn here. Actually, it should X-ray actually doesn't reach much in the stratosphere. Okay, it is mostly confined in the thermospheric region. So both X-rays and extreme ultraviolet are getting used up or absorbed in this region. And the same mechanism, same if it is absorbed, one part of energy will go dissociating the molecules. If it is atoms, it will be ionizing atoms, and another part of the energy will go increasing the kinetic energy of these molecules and atoms. All right. So again, if it is a molecules, the one part of energy will be used up for dissociating the molecules. Okay. If it is an atom, that oxygen atom, then this EUV or X-rays, they will be used up for ionizing this oxygen atom. It becomes O plus electron. So this energy of the X-ray is so high, the photon energy is so high, it can knock out one electron from the oxygen atoms. Okay. Sometimes it also can knock from oxygen one electron from O2, oxygen molecules as well. Okay. It's so much powerful. Sometimes gamma ray as well, but gamma ray content is less, but it's still gamma ray is also there actually. Okay. So the gamma ray, X-ray, extreme ultraviolet, they are all getting absorbed in the thermospheric region, and they are utilized either to breaking or dissociates the molecules or getting ionized. Okay. And part of the energy is also utilized to enhance the kinetic energy of these molecules and atoms. So that is the reason you see the temperature also getting increase and so on. Because if you go up and up, you see that the X-rays and the extreme ultraviolet, these are getting more and more absorbed by these molecules and atoms. But beyond certain altitude, it becomes constant. It doesn't increase or neither decrease. Okay. These are because of some process. Can somebody tell me why the temperature will not decrease beyond certain altitude? Can somebody guess me? Guess it? Anyone? Can somebody guess?
So
So in the
I
thermosphere?
think
Yeah,
it
yes.
is
Is decreasing exponentially.
because of vacuum. Maybe.
Because of?
Vacuum, maybe.
Yes, it is true, partially true. But why? Why there is a vacuum and that may happen? It's not exactly vacuum. If you go up and up, I mean, you will realize that it's not exactly vacuum. There will be some molecules and atoms per cc. It may be very, very less, but there will be, you'll find some molecules and atoms. Even in the interplanetary space also, there will be, it's not exactly perfect vacuum. It is not zero. Okay. There will be some molecules and atoms or some ions, charged particles. Yes, just I mean, you just try it. There is no point of getting shy. Okay. Right. So it is the you see, as I told, that density actually, the atmospheric density decreases with altitude exponentially. Right. So if you go up and up, although we are getting a lot of radiations, they are getting absorbed. But beyond certain altitude, like beyond 800, 900, 1000 kilometers, the density are so less, although these are getting absorbed, but they are not able to transfer their momentum energy to the other molecules and atoms. So the mean free path is so high that there is not enough collisions actually. And if there is not enough collisions, there is no transfer of momentum. So although one molecules may have a lot of energy, a lot of kinetic energy, but the others, since there is no collisions or very infrequent collisions, so the other things are not getting the enough kinetic energy from that particular absorbed molecules and atoms. So that is the reason on an average temperature doesn't increase or neither increase nor decreases. All right, any questions? Okay, I'll say again. So at some point of time, the density is so less that although there can be some molecules and atoms can absorb very efficiently all these radiations, gamma ray, X-ray, extreme ultraviolet, and so on. Okay, but the mean free path is so high, or the collisional frequency is so less, there will be infrequent collisions. Although there are huge amount of radiation can be absorbed by some molecules and atoms, but if there is no collisions or very less collisions, then what happens? This huge amount of energy cannot be transferred to the other molecules and atoms. So that is the reason. The temperature neither decreases or nor increases. It becomes almost constant and constant, so on. So it becomes like that, it's constant like that. Okay? It neither decreases nor increases. All right?
Yes, sir.
Any questions? Yeah, any questions so far? Any questions related to troposphere, stratosphere, thermosphere, and so on? Then beyond thermosphere, there will be exosphere, and the density is very, very less. Any questions? All right, so again, let me repeat again. Okay, so as I told that atmosphere has so many gases, nitrogen 78%, oxygen 21%, and rest of the things are other gases like O2, CO2, then water vapor, and so on, ozone, and so on, other gases as well. Okay, and this Earth atmosphere can be divided or can be classified into several layers based on the temperature. So the region where temperature decreases with altitude, it is called troposphere, and it happens because we are getting away from the secondary heat source, which is the ground from the sun, and as Earth's surface becomes the secondary heat source, and temperature decreases. If you go away from the secondary heat source, obviously temperature decreases, and at some point of time, this trend becomes opposite, and this gradient becomes zero. And that is the reason it is called troposphere, tropopause, where its temperature neither decreases or increases. And beyond tropopause, the temperature starts increasing. The temperature has an increasing trend because of ozone heating. And how it happens? The ozone absorbs ozone molecules. Ozone molecules means O3, right? O3 absorbs UV radiations from the sun, and it decomposes, or you can call it dissociates, with oxygen molecules and oxygen atoms. Okay, so one part of the energy goes in dissociating these oxygen molecules and atoms, and since oxygen atom is very reactive, it quickly recombines to form an ozone again. And another part of the energy goes to increase the kinetic energy of the atoms and molecules. And since these atoms and molecules are this oxygen atoms and molecules are increased, basically oxygen molecules and atoms, these kinetic energy increases. And since there are enough number of collisions happening per second, collision frequency is quite high here in the stratosphere. So that is the reason overall temperature increases. Okay. And in the mesosphere, what happens? And then this this region is called, another region is called just beyond stratosphere is called stratopause, where the temperature trend reverses back and start decreasing with altitude again. This is because of lack of ozone heating and presence of cooling agent like CO2 and hydroxide, OH. And this acts as basically, the process is called the radiative cooling method process actually. This radiative cooling process is nothing but process CO2 molecules or hydroxyl molecules. They emit near infrared and thermal radiations at the cost of their kinetic energy. So their kinetic energy keep on reducing and reducing. And this kinetic energy supply, I mean, these are given, the supply is given from the normal molecules, from the environment. They draw the kinetic energy or the temperature from the environment and they radiate the photons, just like oppositely happens in the stratosphere. And that is the reason temperature decreases with altitude. Okay? And in the mesosphere, there is another part where the temperature starts again increasing. This region is called mesopause region. Beyond mesopause, the temperature again starts increasing. And that happens because of there are oxygen atoms and other oxygen molecules as well, and other molecules also acts as again reabsorbs these radiations. They absorbs radiations. They highly absorbs radiations. This extreme ultraviolet, X-rays, and some gamma rays as well. This region is called thermosphere, where these atoms and molecules that starts absorbing the radiations, these high energy radiations. Okay, UV also actually mostly absorbed here. Some of the part, of course, it is absorbed in the thermosphere as well. But this extreme ultraviolet, it's completely absorbed in the thermosphere. X-ray is also completely absorbed in the thermosphere. This part is not actually correct. Okay, so it doesn't reach actually. Okay, in the mesosphere. So mostly it is absorbed in the thermosphere region. And gamma ray also actually absorbs in the thermosphere region as well. And the same way, the ozone heating happens in the stratosphere. These molecules also, atoms, they also absorbs. Sometimes these have so much of energy, that photon energy is so high, especially like X-ray and gamma ray, they can not only dissociate molecules, they can ionize the molecules and atoms as well. They have so much power. And that is the reason this ionized part of the atmosphere is also formed and is called ionosphere, which will be dealt tomorrow, in the next lecture. But since the kinetic energy, one part of the kinetic energy, one part of this radiations actually also used to enhance the kinetic energy of the molecules and atoms. So that is the reason the temperature increases in the thermosphere. And beyond a certain altitude, the density of the whole atmosphere is so low, there is infrequent collisions. The mean free path is so high that even if there is a absorption by these molecules and atoms, but since the absence of transfer of more momentum energy to the other molecules and atoms, so that is the reason this efficiency is very low, and that is why the temperature neither increases nor decreases with altitude, and it eventually becomes almost constant with altitude. All right. Any questions?
So what is happening with the galactic cosmic rays here?
Galactic cosmic rays. Okay, so you see, these are basically particles, right? Assume. So they actually, these are the EM radiations, electromagnetic radiations, photons, and these are charged particles. So galactic cosmic rays means it is coming from intergalactic space. Okay, not belong to sun or solar system. So they come from outer space. Outer space means outer solar system. So these are charged particles. They are mostly absorbed in the mesosphere, in the thermosphere, mesosphere, and then the stratosphere as well. It sometimes cosmic ray also reaches the troposphere